Good morning, everyone. My name is Faik Hussain. I am from Aeronautical Department, and today my topic is about exploring methods for analyzing hand angular movement using advanced sensors. We will discuss what is kinematics measurement. Kinematics measurement is the process of measuring the motion of objects, including their position, velocity, acceleration, and orientation. Here are some key aspects of kinematic measurements. Types of kinematic measurements. Position measurement measures the location of an object in space using sensors such as GPS, encoders, or potentiometers. Velocity measurement measures the rate of change of object position using sensors such as radar, lidar, or velocity meters. Acceleration measurement measures the rate of change of object's velocity using sensors such as accelerometers or gyroscopes. Orientation measurement measures it measurements rotation or orientation of any object in space using sensors such as gyroscopes, accelerometers, or magnetometers. Kinematics measurement sensors. Accelerometers measure acceleration and vibration. Gyroscopes measures orientation and angular velocity. Magnetometers measures magnetic fields and orientation. Encoders it measures the position and velocity. Radar and lidar measures position, velocity, and orientation. Applications of kinematic measurements. Robotics. Kinematics measurements is used to control and navigate robots. Autonomous vehicles. Kinematic measurement is used to navigate and control self-driving cars. Aerospace. Kinematic measurement is used to navigate and control aircraft and spacecraft. Biomechanics. Kinematic measurements is used to study human movement and motion. Industrial automation. Kinematic measurement is used to control and optimize industrial processes. Introduction on kinematics. This presentation explores the various methods for measuring and analyzing full hand angular kinematics using electromagnetic tracing sensors. It highlights innovative technologies that enhance the understanding of hand movements and their applications in various fields, including robotics and rehabilitation. Kinematics is the branch of classical mechanics that deals with the study of motion without considering the forces that cause it. It involves the description of motion using mathematical equations, focusing on displacement, velocity, acceleration, and time. Kinematics is a fundamental concept in physics, engineering, and robotics, and is essential for understanding and analyzing complex motions in various fields. We will see what are the measurement methods. Here are some common measurement methods in kinematics. Direct measurement methods. Rulers and calipers. Measure displacement and distance using physical rulers and calipers. Tape measures. It measures the longer distance using flexible tape measures. Laser distance meter. It measures the distance using laser based instruments. Indirect measurement of methods. Accelerometers. It measures acceleration using sensor that detects change in acceleration. Gyroscopes measures orientations and angular velocity using sensors that detects changes in orientation. Encoders. It measures the displacement and velocity using sensor that detects changes in position. Optical measurement methods. Photogrammetry. It measures 3D coordinate using overlapping images taken from different angles. Optical tracing systems. It measures the 3D coordinate using camera and reflective markers. LiDAR. Light detection and ranging. Measurement 3D coordinates using laser-based scanning. Other measurement methods. GPS. Global Positioning System. It measures the position and velocity using satellite-based navigation. IMU. Inertial Measurement Unit. It measures acceleration, orientation, and angular velocity using a combination of sensors, radar and sonar. It measures the distance and velocity using wave-based sensing technologies. Electromagnetic tracing sensors. Here's an overview of electromagnetic tracing sensors. Principle of operation. Electromagnetic tracing sensors use electromagnetic induction to detect the movement of a conductive target, such as a metal plate or a coil. Components. Transmitter coil. It generates a magnetic field. Receiver coil. It detects change in the magnetic field caused by the momentum of the target. Target. A conductive material that disturbs the magnetic field. Working. Magnetic field generation. The transmitter coil generates a magnetic field. Target movement. The target moves within the magnetic field which is disturbing it. Induced voltage. The receiver coil detects the change in the magnetic field inducing a voltage. Signal processing. The induced voltage is processed to determine the position, velocity, or acceleration of the target. Applications. Position sensing. Detecting the position of a target in industrial automation, robotics, or medical devices. Velocity sensing. Measuring the velocity of a target in applications such as speedometers or tactometers. Acceleration sensing, detecting the acceleration of a target in applications such as vibration monitoring or crash detection. Advantages: high accuracy. Electromagnetic tracing sensors offer high accuracy and resolution. Non contact measurement. The sensor does not physically touch the target, reducing wear and tear. Robustness. Electromagnetic pressing sensors are resistant to environmental factors such as dust, moisture, or extreme temperatures. Limitation. Limited range. The sensor's range is limited by the strength of the magnetic field. Interference. Electromagnetic interference can affect the sensor's accuracy. Target material. The sensor requires a conductiveness target material to function effectively. Optical motion capture. Here's an overview of optical motion capture. First, we will see what is optical motion capture. It is a technology used to track the movement of objects or people using cameras and markers. It's commonly used in various fields such as film and video game production, sports analysis, medical research, robotics and engineering. How does optical motion capture work? Markers. Small reflective markers are placed on the object or person being tracked. Cameras. Multiple cameras are positioned around the capture area to capture the marker's movement. Software. Specialized software analyzes the camera data and reconstructs the movement of the markers in 3D space. Types of optical motion capture systems. Passive optical. Uses reflective markers and cameras to capture movement. Active optical uses LED marker and cameras to capture movement. Markerless uses computer vision algorithms to track movement without markers. Advantages of optical motion capture. High accuracy provides precise and accurate movement data. Non-invasive doesn't require physical contact with the object or person being tracked. Flexible can be used in various environments and applications. Limitations of optical motion capture. Line of sight. Cameras require a clear line of sight to the markers. Marker illusion. Markers can become occluded or hidden from view. High cost. High-end optical motion capture systems can be expensive. Applications of optical motion capture. Film and video game production. Sports analysis. Medical research. Robotics and engineering. Inertial measurement units. Here's an overview of inertial measurement units. First, what is inertial measurement unit? It is a device that measures the acceleration, orientation, and angular velocity of an object. These are commonly used in various applications including robotics, autonomous vehicles, drones, and wearable devices. Components of IMU. Accelerometers measures linear acceleration in three axes, that is x, y, and z. Gyroscopes. It measures angular velocity in three axes, same as x, y, and z. Magnetometers. It measures the strength of magnetic field in three axes, same as x, y, and z. How IMU work? First, it acceleration measurement. Accelerometers measures the linear acceleration of the object. Angular velocity measurement. Gyroscopes measures the angular velocity of the object. Magnetic field measurement. Magnetometers measure the strength of magnetic field. Data fusion. The measurements from the accelerometer, gyroscopes, and magnetometers are combined using algorithms to provide a complete picture of the object's motion. Application of IMUs. Robotics. IMUs are used in robotics to measure the position, orientation, and autonomous vehicles to measure the vehicle's position, orientation, and velocity. Drones. IMUs are used in drones to measure the drone's position, orientation, and velocity. Wearable devices. These are used in wearable devices such as fitness trackers and smartwatches. Kinematic analysis. What is kinematic analysis? It is the study of motion of objects without considering the forces that causes the motion. It involves describing the motion of an object using mathematical equation. Types of kinematic analysis. Descriptive kinematics. describes the motion of an object using words and diagrams. Quantitative kinematics uses mathematical equation to describe the motion of an object. Graphical kinematics uses graphs and charts to visualize the motion of an object. Data collection and processing. Data collection involves capturing kinematics data from various measurement methods, including sensors and cameras. This data is then processed using software to filter noise and calibrate measurements, ensuring accuracy. The resulting processed data enables researchers to analyze movement patterns and draw meaningful conclusions about hand functions and performance. Angular velocity and acceleration. Angular velocity refers to the rate of change of angular position of a hand, while angular acceleration quantifies the rate of change of angular velocity. Understanding these parameters is crucial for assessing motion dynamics in various applications such as enhancing aesthetic performance or designing excessive devices. Statistical analysis techniques. Statistical analysis techniques are essential for interpreting kinematics data collected from hand movements. By applying methods such as regression analysis, ANOVA, and motion profile comparisons, researchers can evaluate the significance of their findings. These techniques allow for a better understanding of how different factors affect hand dynamics, paving the way for enhancements in clinical practices and technology development. Conclusion. The presentation outlined the methods and techniques used for measuring and analyzing hand angular kinematics, highlighting their significance in both research and practical application. Understanding these measurement techniques allows for improved rehabilitation and performance enhancement strategies, emphasizing the importance of precise kinematic analysis in various fields. Thank you.